Here's our unit circle, or the quadrant we're interested in, and we've got an angle of theta. It's a unit circle. This line down here, that's y. So y equals the sine of theta. Now let's ooch it up a bit. That's a pretty big ooch, but that's d theta. And so what we have here, this little bit here is going to be dy. So the total of y plus dy, this whole total here from top to bottom, is the sine of theta plus that little extra bit of theta. Okay. And now keep in mind that sine theta is y. So let's just kind of cross that out and just put sine theta here. And we're far too busy over here now, so let's clean that up. From here on in, it's just algebra. Let's move this sine theta over here. So we end up with dy equals sine of theta plus d theta minus sine theta. Take advantage of this identity from previous, where theta plus d theta, that's our A, and theta on its own, that's our B. So we've got the sine of theta plus d theta minus the sine of theta equals theta plus d theta plus theta all over 2, and theta plus d theta minus theta all over 2. Let's clean that up a little bit here. And keep in mind that all of this is dy. For very tiny theta, this pretty much disappears. So we got 2 cosine theta times, now the sine of a half theta. Okay? Sine of theta is very close to theta when theta is small. That being the case, we can also say the same thing for the sine of a half d theta equaling almost a half d theta, because d theta is going to be really small. So let's just let's make this is just a half d theta, a half d theta here. These two cancel out, and we've got dy equals the cosine of theta times d theta. And remember, dy by d theta, that's the d sine theta by d theta. So that just equals the cosine of theta. 2 points about Thompson's method. He assumes this pretty quickly, and you may be able to justify it looking at the diagram, but I did a whole video on this. Am I pointing in the right direction? Yeah. He's also very algebraic, and I also did a video previously which is more geometric. So let me know in the comments which one you like better, if at all. Now let's take advantage of the fact that cosine of theta equals the sine of theta minus pi by 2. If we want to do the derivative with respect to theta of the cosine, we already know how to do the derivative of a sine. So we're going to use the chain rule on this and say that that equals the cosine of theta minus pi by 2 times the derivative with respect to theta of all of this stuff, which is just 1. The derivative of cosine theta is just cosine of theta shifted pi by 2 degrees to the right, which is the negative of sine theta. I'm going to completely depart from Thompson in this next one. The tangent of theta equals the sine of theta over the cosine of theta. So taking the derivative of that with respect to theta. We just need to apply my favorite rule, the quotient rule. So that derivative is going to have cosine squared in the denominator, and u prime, that's the derivative of sine, which is cosine, times v, so that's going to end up being cosine squared, minus v prime, which is going to be sine of theta, but it's negative, so this becomes positive, times u, which is sine of theta, so that's going to be sine squared theta. But all of this on top, that's just 1, so it's 1 over the cosine squared of theta, which we have a name for, and that is the secant squared of theta. That is your derivative of tangent. Bob is your uncle.